Good evening, one and all. Today I am going to show how to control the closed loop control of buck converter using DSPF28379D only with MATLAB block sets, no coding. So with the help of MATLAB block sets, how we have done. So first, this is the actual diagram of buck converter. So in this, first we are sensing the output voltage, and we are using here, instead of compensator, we are using PI controller along with the ADC channel, and after that we are using EPWM block set, and with that we are getting a pulses, PWM pulses, that is given to the driver circuit, right? So that driver circuit is directly connected to the MOSFET. So this is firstly we are going to show you, and the main important thing is ADC sensor. And now what is the ADC sensor we have used? This is the voltage sensor we have used. So actually this is measuring 25 volts for Arduino purpose. So for 25 volts means it is equivalent to 5 volts for Arduino, but we are using DSPF28379D controller, which is only allowable voltage of 3.3 volts only. So for that we will scale this 25 volts to 15 volts, so that is equivalent to your 3.3 volts. So the ADC sensor maximum voltage we can give in this buck converter 3.3 volts, which is equivalent to 15 volts actual voltage of output voltage. So that is the DC regulated power supply we are using, and this is the one MOSFET only we are using. Remaining 3 we are not connecting anywhere, and we are connecting this high frequency inductor and as well as one capacitor, and we have high frequency multimeter, Rishabh company multimeter, which is used to measure the current for high frequencies, and this is a normal voltmeter. After output voltage, that means pure DC voltage, it will measure. And coming to here, this is the DSPF28379D board, and this is the driver circuit we are using, and TLP250 driver. With this driver we are sending 15 volts to MOSFET for gate and source. And now this is the DC, load voltage rheostat we have connected. So based on this voltage we are sensing through this sensor. This is ADC sensor which we have discussed. This ADC sensor pins I have connected to here, which is A0 pin for the DSPF28379D board. Now I will show how practically we are working on this one by using this MATLAB software. So first I will explain you. So this is the reference voltage we have taken. We can take 3.3 volts, which is equivalent to 15 volts, or you can also write here a constant value of 3300, and if you want to go for lower voltages also you can go, but maximum voltage is 15 volts because of the limitation of the, so maximum voltage is 15 volts because of the limitation of the voltage sensor. So we are using a low voltage sensor. So and now we have to measure the ADC signal from here using this block, and this is a 12-bit ADC channel. Now we are comparing with this comparator, and the error is processed through the PI controller, and that is given to the EPWM block sets, and with a multiplication factor of 10,000, and we are working with for 5 kHz switching frequency. You can go for 1 kHz switching frequency to 10 kHz, which is ripple will be going to be less, and the PI values which I have tuned as per my requirement. So I have tuned for PI values 0, 0.1015. So I have tuned like this. You can also tune your values like 0.1, 0.02, like that. You will get it some exact values. So this is the block diagram. What I am doing, this is similar, equivalent to your this block diagram. That means first we are sensing the voltage using voltage sensor, and that is given to the PI controller. Just now I have shown the PI controller, which is a PI controller, and that after PI controller we are using the pulse width modulator. The pulse width modulator is nothing but here EPWM block, and finally we are connecting, the output is connected to the driver circuit of this MOSFET. So this driver circuit is connected to over that through patch cards we have connected. Now I will show the how this PI controller will work using MATLAB software by changing the load and by changing the voltage setting.